Binary code. Digital signals are based on binary code. Binary means two parts. And here's a clue by this picture. The code is going to be consisting of zeros and ones, unlike the dots and dashes of Morse code. And just another point, perhaps you notice that E is represented by the simplest symbol. Why would that be? E is the most common letter in the English language, so E just gets a dot. Binary code is more effective and powerful than Morse code for computer and digital transmission use. It might look more confusing to people, but it's been designed for computers and digital transmission. Morse code uses combinations of two characters, the dot and the dash, with spaces to represent numbers, letters, or symbols. Binary code uses combinations of 0 and 1, or off and on, to represent information. Binary code does not require spaces. Binary code is based on the binary number system, or base 2. We're going to cover that in more detail shortly, but basically we just have two numbers. We don't have 0, 1, 2, 3, 4, etc. We have a 0 and a 1. It assigns a pattern of these binary digits, or bits 0 and 1, to each character, and by character we mean a letter or an instruction like stop transmission, start transmission. Let's represent one bit by a box that can have either a 0 or a 1. So here's a bit, and here's another bit. And you can have either a 0 in it or a 1. So one bit can either have a 0 or a 1. I know I just said that, but let's say it in a different way too. One bit can represent two different characters, 0 or 1. It's kind of key to everything we're going to be doing. Let's put these two bits together. Here's one bit and here's another bit. How many ways can we fill them up with either a 0 or a 1 and get something different? Okay, we can have a 0 and a 0. That's a good place to start. Or we could have had a 1 and a 1. Now let's just go from the top again. We'll keep the first 0, and instead of the second 0, we'll put a 1 in. Is 0, 1 different from 0, 0 and 1, 1? Yep. Then we'll work up from the bottom. We'll keep the 1 on the left side, and we'll change the 1 to a 0 over here. Now we have 1, 0. Are these four different ways of organizing 0 and 1? Can you think of any others? I hope not, because there aren't any. Okay, so we have four different characters can be represented by 1 bit and 2 bit stuck together. Okay, now let's smush 3 bits together. 1, 2, 3. How many different combinations of zeros and ones can we get here? Well, I'll take the easy one again. We can go 0, 0, 0 or 1, 1, 1. Those are the easiest, right? So I'll just fill this one in like that. That would be 0, 0, 0. What other combinations can we make? All right, well, first let me erase this. And I'm not going to go through each one, but the first thing you can do, well, maybe I will. First thing you do is change the last 0 to a 1, and that gives you 0, 0, 1. Then let's just change the second 0 to a 1. And then let's change both the second and third to a 1. All right, so now we've got 4 choices. Now let's put a 1 in front of everybody. Go 1, 0, 0. And then we'll add a 1 at the end. And then we'll take away that 1, put 1 in the middle. And then we'll put them all back. So there you go. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 unique combinations when you have 3 bits. So please look at this for a while, pause the video if you need to, and see if we could have fit any other combinations in there. Don't think you'll find it. Now, I didn't do the one for 4 bits, but let's say it's 16, which it is. You can go try that if you'd like. It'll work. So we have 1 bit. That's when you have 1 box. You can have 2 unique characters. Right? You could have either the 0, 1 or the 1, 0. When we had 2 bits, you could get 4 characters. 3 bits gave us 8. And then this you're going to have to trust me on, but feel free to verify it, because that's a good way of doing science and math. So 4 bits give you 16 characters. Do you see any pattern there? It's a little tricky, but try and figure it out. Okay, here's our table. when we had 1 bit, you'd had 2 characters, right? You had a 0 or a 1. We're going to call that 2, which is 2 raised to the first power. See, we're bringing in exponents here. And look at that first power. What does that square with? How many bits there are? When we had 2 bits, we had 4 characters, which is 2 times 2, which is 2 squared. And look at that. There's a 2, here's a 2. 3 bits, we had 8 characters. That's 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. That's 2 raised to the third power, 3 bits. And then 4 bits, we had 16 characters, which is 2 to the 4th, and there's the 4 matching that. So the number of characters that can be represented by n bits is 2 to the n, where n is the number of bits.